So I was re-explaining the concept of how we can produce the simple harmonic motion. When you put a vertical slot, the action here will be the action of the pivot on the rigid body transmitted will be normal to contact. So it will be along X direction. So what will cause motion of the slider will be the X component of the delivered force. And this will lead to give this link, which is slider number 4, which is your rigid link, okay? It will give it a velocity equal to the X component of the velocity of this point. Now, how to determine what is the expression of Vx? Then all you have to do is to find the projection of velocity of the pivot here. You know that this point is doing rotation about a fixed point, and you can play with the angular speed. They are saying that if I impose a constant angular speed, I can create simple harmonic motion. Why? Because if you impose omega constant, this means that the linear velocity of your pivot, which is always perpendicular to the radius, is equal to omega times the radius, okay, which is a constant. Now, what will be variable is the projection of this velocity on X direction. Okay, and for example, when the crank was at this position, the velocity was vertical, so the X component was 0. Now, if I move to another position, if I consider the position here, we said that this angle here with the horizontal is 90 minus theta, okay, where theta is the angle between the horizontal and the crank. So this is theta, and this is 90 minus theta. So to project the velocity along this direction, we'd have just to do V of X is equal to minus R omega sine of theta. And theta is, because omega is constant, the angle theta can be related to the angular velocity by omega times t. So this is what we call this function, a constant times sine omega t, is called a simple harmonic motion. So this is the velocity, and if you want to get x, you integrate. Also, x will be varying in harmonic motion. It will be proportional to cosine omega t. Okay, is it clear for the one who asked the question? Any other question on this? Please interrupt me directly when you have a question. So now, another possibility of transformation is the transformation shown here, okay, by using a cam follower system. So if you look at the following example, what are the modifications done compared to the initial 4-bar linkage system? The modifications you did here is that first, the number of links is reduced. So if you count links, you have the ground. The ground is counted as link 1. You have the cam, which is link 2. And you have the follower, which is link 3. So you have 3 links. Already, you reduce the number of links compared to the 4-bar linkage. So you use now strategy number 3. But if you look at the type of joints, here you have full revolute joints. However, here at the contact between the cam and the follower, you have a half joint, because this is a roll slide joint. You can have rolling, you can have sliding between these two parts. So this is a half joint. So in total, you used 2 strategies here. You used rule 2, which consists on replacing a full joint by a half joint. And also you used rule 3, which is to reduce the number of links by, you removed 1 link. So the combination of both is rule 4. So this is what you did here. So you can expect that there is no change in the degree of freedom. And here the degree of freedom will be 1. Now, if you want to make the analogy with a 4-bar linkage system, you still can figure out the presence of effective links. And as I told you, effective links are not physically present, but they are, you are producing same effect as if you have these links. Okay, so how we can detect the similarity with 4-bar linkage? Here we can consider that having the command follower is similar to have 4 links connected to each other. Why? Because if I consider a certain line and I follow it, a line of my cam and another line of my follower, and I follow these lines, okay, I can consider at each instant that these lines are through certain points are connected because of the line of contact between the cam and follower. Okay, now this line of contact has a particularity that it's having changing lengths. Why it's having changing lengths? Because of the profile of the cam. Okay, due to the profile of the cam, I don't have always same distance between this point and the contact one.